Hello, ladies and gentlemen. Welcome to day 4. Happy Tuesday. So far in algebra, we've talked about a bunch of different things. So let's start off with a little bit of a review. We're not doing a whole review, we're just going to list some stuff. So far, we've covered linear graphs, which is x to the 1 power. And this might look like something like x equals y equals x plus 3. We've covered quadratics, which is when you have x to the 2nd power, and that might look like y equals x minus 2 squared plus 1, or something like that. We've covered cubics, which is when x is to the 3rd power, and that could look just like quadratics, except you substitute in a 3 for the 2. And then lastly is what we're talking about today. Not lastly, but additionally what we're talking about today is something called a square root function. This looks like either the square root of x or x to the 1/2 power. Keep in mind, if you didn't know, these two are saying the exact same thing. A radical sign is just saying to the 1/2 power. So this is what we're covering today. Now, to really be ready for today, we're going to need to go through something. It's a long list, but it's important. And it's the list of our perfect squares. Okay? They're going to come in much handy today. Much handy? That's not even a thing. They're going to come in handy in a major way. There you go. So our list of perfect squares are the square root of 1, the square root of 4, the square root of 9, the square root of 16, the square root of 25, the square root of 36, the square root of 49, the square root of 64, the square root of 81, the square root, it's a long list, the square root of 100, the square root of 121, and the square root of 144. I got a little squished at the bottom. So the question is, what are each of these? And it's probably the easiest math assignment I've ever asked you to do to fill this out. It's literally just numbers going up from 1 to 12. It's going to be important to keep these in mind because if you don't, you're going to end up having to graph the number 2.147, which I don't know about you, but trying to guesstimate where that is on a graph is not fun. So please, make life easy for yourself and use this list. So, perfect squares. Let's talk about what this graph looks like. So, we have y equals the square root of x. We're going to graph the basic function like we have every time. So just like every time, we're going to do our xyt table. 1, 2, 3, 4. And as you're about to find out, the xyt table doesn't work the same way for these, annoyingly enough. So let's see what happens. So where's our vertex? Do you have an h? No. Do you have a k? No. Great. So let's go up 2 and down 2. And let's start with -2. So if I plug in my -2, y equals the square root of -2. What's the square root of a negative number? Well, if you don't remember, it's imaginary. Do you know where to graph an imaginary number? Because I don't. What if you tried y equals the square root of -1? The same. In other words, for square root functions, we're not going down. Because if we go down from the vertex, we're going to end up in negative territory. And when you go into negative territory, you're graphing negative numbers, and you can't graph negative numbers. So what we're going to do for these is we're going to go up a few points. Okay? We're going to end up with 4. So we're going to do 1, 2, 3, 4 points. Okay? So we're not going to do the usual 5. We're just going to have to do 4. And just to give you a little heads up, taking the square root of 1 is easy. Taking the square root of 2 is not. In other words, we're going to not use this table. Okay? So let's start over. Let's start over armed with our new knowledge. Remember, with the square root functions, we're just going to be doing 4 points, and we're starting with the vertex. So it's still 0, 0. So where do we go from here? Now from here, we're going to have to use some creativity, okay? It's one of the few times we get to use creativity in math, because we want to avoid taking the square root of any weird numbers. I don't want you to graph the square root of 3, the square root of 5, the square root of 6. Those are all really awful numbers. We want to be able to graph the square root of these, right? Because these are easy. If it says the square root of 4, you know it's 2. It saves time. So what we're going to do is do everything we can to plug in numbers for x that will give us easy square roots. So what can we take the square root of, starting from 0, that's going to give us easy numbers? Well, we can start with 1. 4 is the next easy one. And then 9 is the next easy one. Because if you just take the square root of 1, you get 1. Square root of 4, you get 2. Square root of 9, you get 3. I hope that makes sense. We're trying to avoid taking the square root of 2. So when we graph this, what does it look like? One, 2, 3, 4. This is 9, so I'm going to have to count all the way to 9. 5, 6, 7, 8, 9. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So, graphing the point 0, 0, that's at the origin. Then I go over to the right 1, and then up 1. I go over to the right 4, 1, 2, 3, 4, and then up 2, 1, 2. I go over to the right 9, and then up 3. Now, the tricky part about tracing this one is that you can't go negative, right? You can't go any further down than 0. So you start here and then only go out. It's not like all the other shapes we've done where there's 2 arrows. There's only 1 for these because you can't go the other way. And you'll know you have the right shape because if you look at it sideways, it should look like 1/2 of a parabola. So the rough shape you're looking for is that. That's sort of the shape you're looking for. So let me show you where the real creativity comes in. Let's do an example. Oh wait, no, before I do that, important trick for this. What do you think the domain is? The domain for these is a little different than a lot of domains. So we can't go any further down than 0, right? That's the furthest we can go, or we start taking the square root of negative numbers. So for some of you guys, the way you'll write it is x is greater than and equal to 0, because it can't go lower than 0. For you other guys, you would write it starts at 0, and it goes all the way to positive infinity. Oh, I'm sorry. Now, depending on your class, you're going to write this slightly differently, but you know who you are. All right. So let's look at example number 1. And I'll probably only be doing 2 examples, and then we will get to homework, because this lesson does not need to be any longer than it needs to be. So let's look at y equals the square root of x minus 2 plus 2. The square root of x minus 2 plus 2. Now, before you get a little bit of a head scratcher as to how you're supposed to figure out anything here, remember that this is literally just saying the quantity of x minus 2 to the 1/2 power. In other words, this is still h, and this is still k. So just because there's a radical doesn't mean you have anything janky going on. In fact, a good note to make is The radical, which if you didn't know is this, counts as parentheses. Okay? So let's just jump into it. So making our XYT table, I told you we're only using 4 points here, so I only need to draw 3 lines. And the reason for that is if we go 5 points, you're going to have to start graphing the number 16. And I don't think you want to count that far out. So we're trying to keep the graph smaller. So where's our vertex? This is positive 2, and this is positive 2. So this is a little weird because in the last one, we had to start at 0, 0, and then it made sense. Oh, 0, 1, 4, 9. Easy. This one not so much because we're stuck with 2's. So the trick is we want to move up in the same increments we did before, as in the 1, 4, 9, 16, but we have to start with 2. So we can't start with 0 this time. So this is where the creativity comes in. X minus 2, right? So if I have x minus 2, I'm starting with 2. What's the next biggest number on my square root list? Above 2. I have 4. So what minus 2 gives me 4? If I have 6 minus 2, that would give me 4, right? So let's substitute in a 6. Because then if I have the square root of x minus 2 plus 2, I substitute in a 6, then what is 6 minus 2? Square root of 4. And what's the square root of 4? 2. 2 plus 2 is 4. So the goal here is to find an x that gives you a nice number, one of these ones, underneath the square root. Because if you start plugging in anything else, that's going to get really wonky really fast. So let's do one more. We did 4. How do we get to 9? What minus 2 gives me 9? 11 minus 2 gives me 9. What's the square root of 9? 3. What's 3 plus 2? 5. We plugged in 11, and we get 5. Now, do you want to graph a number bigger than 11? I don't really. I'm giving you permission to cut this down to 3 if your numbers get too big. Because these ones are a little weird. So I have 3 points. I have my vertex, and I've got 2 points that gave me perfect square numbers. So now we can graph those 3 points. I go all the way out to 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Highest I go is 5. Then I go 4 every other way. I start at right 2, up 2. Then I go to right 6. 1, 2, 3, 4, 5, 6. Up 4. 1, 2, 3, 4. And then I go out to 11. Up 5. 1, 2, 3, 4, 5. Does my shape look like half of a parabola? Yes, it does. Is my vertex at positive 2, 2? Yes, it is. Then I did it correctly. So the hard part for this is for you guys is going to be being creative, getting x values that when you plug them in to your parentheses, they end up giving you a perfect square. But I trust in you guys' mental ability to do that. I'll do one more example. Let's do one that has a stretch. Y equals, let's do 2 on the square root of x. I don't know, minus 1. I want to give you guys examples. I'll do 2 on the square root of x minus 1. Let's make it a long boy. So, XYT table. I told you guys we can shrink it down to 4 or 3 if it gets really bad. But let's assume we can do 4. Where's my vertex? Do I have an H? Yes, I do. Do I have a k? And no, I don't. So I'm starting at 1. Let's look at my perfect square list. What's the next biggest perfect square? 4. What can I plug in as x to get 4? What minus 3 gives me 4? And if you want to think about it like this, I'm sorry, what minus 1 gives me 4? How would I do this? I would add 1 to both sides and get x equals 5. So if I plug in 5, then I get 4. So I plug in 5 and I get 4. Oh, I'm sorry, I'm being silly. I'm being very silly. If I plug in 5, then I get 4. So my equation would be 2 on the square root of 5 minus 1. That simplifies to 2 on the square root of 4. What's the square root of 4? 2. What's 2 times 2? 4. Oh, so I do get 4 either way. Great. That was convenient. So now I did 1. I got 4. The next biggest one I have is 9. So what minus 1 gives me 9? Well, it looks like it's 10. So what happens when I plug in 10? 2 times the square root of 10 minus 1. 10 minus 1 is 9. Square root of 9 is 3. 2 times 3 is 6. So when I plug in 10, I get 6. Now, do you want to go much bigger than 10? Because I don't. Then how about this? Let's agree not to, because that's a big graph. I got to count all the way to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The highest I go is 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4. Okay, my vertex is at right 1. I don't go up or down. Next point is count over 5, count up 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. My next point is count over 10, then count up 6. 1, 2, 3, 4, 5, 6. When I trace this sucker, what do you notice already about the difference in appearance? Do you notice how much taller this looks than that? That's because, what is this 2? Remember, our equation is y equals a times the quantity of x minus h plus k. What is the a doing? It's a vertical stretch. So let's go backwards and let's fill in all of our transformations on these equations so far. This 2, because it is bigger than 1, right, is a vertical stretch by factor of 2. What is this minus 1? This is my h, right? And h is for horizontal shift. Which direction? It's negative, so we switch it to positive, so we're going right 1. Let's look at this one. What were our transformations here? My h was negative 2, so h is for horizontal shift. Which direction? If it's negative, I flip it to positive, so right 2. And this is my k, which is vertical, so my vertical shift is up 2. Then looking at the first problem I did, I had no transformations because there were no numbers. It was just plain old square root of x. So this is as long and as difficult as square root functions get. So let me give you guys a couple for homework, and then we will catch up tomorrow for absolute value functions. So let's say number 1, we'll only do 3 today. Y equals the square root of x plus 2. Number 2, we will do y equals 2 on the square root of x plus 3. And for the third one, let's do a challenge problem. Y equals negative square root of x plus 1. Okay? Now, I'm not trying to trick you here. The negative is not inside the square root, so this isn't going to cause any issues. The negative will just change what you plug in. As in, keep in mind, if you plugged in a 1 here, what's 1 plus 1? 2. So you'd have the negative square root of 2. Or let's say this was a bigger number. Let's say you did 3. Negative square root of 3 plus 1. 3 plus 1 is 4. Square root of 4 is 2, so you'd end up with negative 2. This isn't going to cause any jankiness with your table, don't worry. So here are your 3 problems, and I just kind of spoiled one of the points for you. Keep in mind, today you're supposed to be having a quiz due between the hours of 10 and 12:30. I think it's between 10 and 12:30. So make sure, if you're just watching this and you forgot about it, to go get the code from GroupMe, plug it in. It's a timed quiz, and make sure to get that done. Other than that, please send me any questions you have on this, and I'll review this homework tomorrow. I wish you all well. I'm praying for you guys. God bless.